All right, we're back. We're going to look at the other four trig functions today and learn their derivatives. So the other day we talked about the derivative of sine x is cosine x. So that's pretty straightforward. The derivative of cosine x is negative sine x. And then today we're going to look at our other friends. Let's start with the derivative of tan x. So the derivative of tangent x, and this has a super cool proof that shows you why this works that we're not going to get into, but you should look up the proof of the derivative of tangent x because it's pretty cool. Okay, the derivative of tan x is secant squared x. All right. Then let's move over to the derivative of cosecant x. The derivative of cosecant x, now brace yourself, it's negative cosecant x times cotangent of x. Okay. The derivative of secant x is secant x times tan x. And finally, the derivative of cotangent x is negative cosecant squared x. Now, if we were in school and we were meeting face to face, I would give you like 900 quizzes on this. So it's worth memorizing. It's definitely worth writing down right now and taking a screenshot of it. Okay, so there's a couple patterns to be had here. So like there's negatives in two of them. This one's squared. You can find some patterns as you go. So we need to have those essentially memorized. I want to remind you that these negatives are just like having a -1 in front, and that this squared means the whole thing is squared. Okay, so let's take a look at some examples. Okay, let's start with tangent. So what if we have the derivative of tan 6x? Okay, the derivative of tangent is secant squared x. Well, x in this case was 6x, so it's going to be secant squared 6x. Now, we then need to multiply by the derivative of 6x, which is 6. So that 6 is going to move to the front because it's just being multiplied. So the answer is 6 secant squared 6x, right? Because we had chain rule in there. So that seems pretty straightforward. Let's try another one. What if we have the derivative of cotangent 30x? All right, so the x here in this case is 30x. So the derivative of cotangent is what? It's negative cosecant squared x, and in this case x is 30x. Then we need to multiply by the derivative of 30x, which is 30. Rewrite this. That negative, is going to multiply with this 30. So that's going to give us negative 30 cosecant squared 30x. Okay, not bad, not bad. We're doing okay. Okay, let's do secant. What if we have the derivative of secant secant of 2x to the third. Okay, so again, 2x to the third is the x we're dealing with, and the derivative of secant is secant x tan x. So secant something, tan something. This is not chain rule. That's just straight up its derivative. So our something, in this case, is 2x cubed. And then we need to use chain rule and multiply by the derivative of 2x cubed, which is 6x squared, right? Yep. So we rewrite, clean up this answer, and we have 6x squared secant of 2x cubed times the tangent of 2x cubed. That's it. Okay, and then the last one we can take a look at is, let's do the derivative of cosecant. So the derivative of cosecant, I don't know, let's say 6x to the fourth. So the derivative of cosecant is negative cosecant times the cotangent of that. And in this case, our x is the 6x to the fourth. So we're going to put that 6x to the fourth right back in. Then we're going to multiply by the derivative of 6x to the fourth, which is 24x to the third, because there's our chain rule. Similarly to cotangent, this negative is going to multiply with this 24x to the third, because that's just a negative 1 sitting in the front. So we clean this all up, and we have a negative 24x cubed times the cosecant of 6x to the fourth times the cotangent of 6x to the fourth. And there we go. Okay, so that's how your derivatives work. Pretty straightforward. You just have to memorize them. They're ugly. Use chain rule. It's all good. Now, what happens if we just throw a small little wrench in things? Like, let's say we have y equals 2x plus 3 tangent 5x. That's fine. If things are adding, you just find their derivatives individually. So, okay, y prime, the derivative of 2x is 2. Good, good. Some rule says you just add them together. What is the derivative of 3 times tan of 5x? Well, 3 times the derivative of tan x. The derivative of tan x is secant squared 5x times 5. So that 5 and that 3 will multiply together, just kind of like that 3 is just in front. So if we multiply that through, we get 2 plus 15 secant squared 5x. We could have done product law right here, and it would have worked out because the derivative of 3 would be 1. So by the time this is all done, we'd be right back where we were. Or the shortcut is just to multiply it right in front. Okay? All right, now let's look at what actually happens when it gets a little wild. Let's look at product law. All right, so what if we have y equals secant x tan x? This is product law. This is our f of x. Oops. This is our f of x. This is our g of x. Okay? We're going to follow product law. We're going to say g, f, f, g. And we're just going to follow our pattern, and it's going to be just fine. So, g tan x times f prime. Well, the derivative of secant x is secant x tan x, okay? Plus, so let me be really careful here. Here is g, here is f prime, plus f, secant x again, okay? That's f, times g prime. So g prime, the derivative of tangent, is secant squared. So this is my g prime. Okay, so this is good. And then all we're going to do is simplify this. So let's look real closely. You have tan x times tan x. Well, that is tan squared x. Then you have a secant x. It's all by itself, so secant x. Over here, you have a secant x and then 2 more. So 1 plus 2 is 3. Winner, winner, chicken dinner. Secant cubed x. And that's your answer. Not bad. What if we do that again? Let's get a little bit crazier. What if we did y equals secant cubed 2x? So first, let's remember this, that I'm going to rewrite this as secant 2x cubed. So we're going to have to do double chain. So we're going to say that y prime is 3 times something squared. That something is secant 2x. Now we need to multiply by the derivative of secant 2x. The derivative of secant is secant something times tan of that thing, and our thing is 2x. And now we need to multiply by the derivative of the 2x, which is 2. So if I go back and I put this all together, this is kind of crazy. Let's start by looking at whole numbers. We have a 3 and a 2. Those are my only whole numbers. So I've got a 6, okay? Let's find secants. I have a secant 2x here. In fact, I've got 2 of them. And here's another secant 2x. So that's actually secant cubed 2x. And then finally, there's a tan 2x. So we'll multiply by the tangent of 2x as well. And we're done. Okay, our final example is straight up product law, or even quotient. Let's look at product. So let's say we have y equals x squared times, let's go secant x. So secant, we'll say secant 2x. All right, so y equals x squared times secant 2x. So again, this is product. Here's my f, here's my g of x. And we're going to go g, f, f, g. We're going to add them together, take the derivatives. Okay, so follow, be careful. We can do this though. All right, so y prime equals g secant 2x times f prime. The derivative of f prime, or the derivative of f is 2x. Okay, cool, good, we got it. Plus f, x squared. Okay. G prime, the derivative of secant x is secant 2x times tan 2x. And now, chain rule, we need to take the derivative of 2x, which is 2. Okay. Clean this guy up. Y prime equals 2x secant 2x plus, be careful over here, this x squared and this 2 can be multiplied together at the beginning. So 2x squared secant 2x tan 2x. And that is legitimately the ugliest answer on the whole planet, but it's totally valid. All right, that's all I got for you.